This example is different. We are going to multiply the two matrices. The process is same, but to verify the feature is something different. This is what we have learned in the system. First of all, is a row 1. We just spend some time over here. So we call it row 1. What is the column? We have got 3 columns there. Column 1, column 2, column 3. So the first matrix we are talking about is a row 1, column 3. 1 row horizontal, 1, 2, 3. We don't need a vertical line. It's 3 columns. The next matrix we have is a row 3. Why is a row 3? Is 1, 2, 3. 3 horizontal line involves. That's why it's called row 3. And it's a column 1. Why? Because it's just simply one column. The multiplication part is very simple, but how the result is going to look like, that's little bit different. Pick up the left value from the row times column and pick up the n value from the row column. So our resultant matrix on this occasion, when we multiply the whole matrix by another matrix, not by a number, the answer will be a 1 times a 1 matrix. That's the different part of this one. If we understand it, rest is very easy. We pick up the information from the row of the left one, so it's the left times the right value. 1 times 1 matrices. Let's see how that works. So what we do is A times B. There is different, the row and column is not same for this matrix, is different. So what we do this time, we pick up the first number on the left and the top number on the right. So how we do it, we always go from left to right and we always come from top to bottom. If we take that strategy, because when the row and column changes, sometimes it creates confusion. That's why we are just spending some time. So what should be the first number? And the answer is going to be basically one answer. That's the amazing part. First, we just write, get prepared for the resultant matrices. So the first value, multiply the left, start from the left, start from the top. The reason we have to multiply is going to be 7 times 2. So take the 7 and take the 2 and multiply them. We will do the multiplication later. Now, previously we wrote matrices without any sign, but when we multiply two matrices with each other, no sign needed to be written. We add, and now what we do is we pick up the second number from here and the second number from there and write it over here. Pick up the 3, multiply it with the same. So move from 1 to location 2, from top to bottom second location, and put a positive sign in between. This one I'm going a little bit slow. The next term, obviously there should be another positive sign, but we are going to pick, we are going from left to right. Remember, left to right, yes? Let me just put the sign properly. Left to right, top to bottom. We started with 7 and the 2, wrote it over here, put a plus, 3 and the 2 going from left to right, coming from top to bottom. And finally we pick the 1 from here and we pick the last value. So from left to right is the last value, from top to bottom that's the last value. So get the 1 from there, get the 3 from there, and multiply the two values. And we knew from the beginning it was supposed to be a 1 by 1 matrices. That's the reason all these numbers has to be multiplied, and at the end they have to get added. So we write another matrix term. 7 times 2 is 14, plus 3 times 1 is 3, plus 1 times 3 is another 3. And we add the 3 values because there is no columns or rows in between that. And we add the 14, the 3, 3, 3, 6, 14 and 6 is 20. And we knew it. It's a row 1, column 1 matrix. Done. So when we do the multiplication between two matrices, this is the system we follow. If we understand it, that's the reason we add these terms from location, left to right, top to bottom, and we just put the first, second, third, and in between. The law is always add the terms in between. And this is how we do multiplications. We are going to have a different example. I'm just speaking on the previous example on this video. We have done it. It's in the previous video. The reason we added it, because we know the answer was supposed to be a 1 by 1 matrices. That's the reason we multiply the location wise is done, but we added the value so that we end up with a 1 by 1 matrices. But what about if we do something different? Is A times E. What about if we do B times A? Let's see. Now, B was the second matrix, A was the first one. We just switch it. And B was row 3, column 1, and A was row 1, column 3. But what about the resultant matrix for this one? A times B, we have done it. We added it because it was a 1 by 1 matrix. But now we know the future is going to be a 3 by 3 matrices. If we keep on the addition, is going to end up with a 1 by 1 matrices. That's the tricky part. Take some time. 1 by 1 matrices, we just chose to put addition because every number added and ended up with a 20 on the previous video. But this one, we are prepared for B times A, and we are preparing for 3 by 3 matrices. So the way we do it, we prepare for a 3 by 3 terms. Now, this 2 will get multiplied with all these 3 numbers. This 2 will get multiplied with all these 3 numbers. And all these 3 numbers is going to be the top 3 numbers. So it's row 1, and we have 3 columns. So we have to make sure that we get those 3 columns. And the top row is decided by the 2. 2 is the deciding factor of the row 1. And all these 3 columns will be changed by 2 times 7, 2 times 3, 2 times 1. So 2 will get multiplied with the first number 7. Pick up the 2, pick up the first number. Row 1, column 1. We are keeping the same row 2, but we are going to column 2. Pick up the number from column 2. We are keeping the same row, and the column 3 is going to be 2 times the 1. It's animated, so I'm not talking extra for that. And we are not writing any positive sign because we are prepared for a row 3, column 3 matrix. Row 1 is done with the 3 columns. Now we move to row 2. And we just use the row 2 with the 3 numbers. So get the 1, get 7 from there. Row 2, column 1. Row 2, column 2. That's row 2. Pick up the 3 from there. And obviously we are multiplying two values. No sign of positive because we are prepared for the 3 times 3 matrices. Some words I'm repeating. Some student needs some more help. Some student doesn't need that much help. So being the reason it's an online course, I try to make it easy for every student. So finally is the row 2, column 3. So it's the 1 times that 1. And we will multiply it later. Then we move to the row 3. That is the preparation, row 3. And 1, 2, 3. It will be column 1, the column 2, the column 3 will be controlled by the row 3. So it's going to be 3 times the 7. Pick up the 3 from there. Column 1. Get the same row. Pick up the column 2 number from there is B times A. And get the 3 and choose the last number from there. What is the symmetry? There is a symmetry. Finally, okay, let's finish it. Then we will have a very nice symmetry over here. So we will multiply each value is 1, 2, 3, 1, 2, 3. It will be having 3 rows, 3 columns. The simplified version is 7 times 2 is 14. 3 times 2 is 6. 2 times 1 is 2. 1 times 7 is 7. 1 times 3 is 3. 1 times 1 is 1. 3 times 7 is 21. 3 times 3 is 9. And 3 times 3 is 1. That's the final answer. So A times B, which is the previous one, is not same as B times A. What is the symmetry to watch? Some students, when they practice a lot, just look at this number. 731 is repeated in 3 rows. Just look at the symmetry. We did it step by step, or sometimes you can just pick up the 731, write 731, 731, 731. Why? We know it's a 3 by 3 matrices. Very easy, right? Then we pick up the other one, the matrix B. Write the matrix B, write the matrix B, write the matrix B. So we are picking the column, writing 1, 2, 3 columns, and picking the matrix A, write 3 rows. And this is the way it works. And we just do the simplification. 731 repeated horizontally, 213 repeated vertically. Row 3, column 1. So if we use that technique, it's very easy, but I'm supposed to teach the formal notation the way we did step by step. And this is done. This example is a complex one. Not to worry. We will do it by the formal way, the way I am supposed to do. Then we will find a shortcut or a synthetic method to do it. So basically, no values. If we have values like this, it's a row 1 horizontal, row 2 color coded, horizontal, column 1 vertical, column 2. So the first matrix is 2 row times column is a 2 by 3, and the second one is a 3 times 2. So what is going to be the resultant? Some students might find the formal is easier, some students might find the shortcut is easier. Let's try both. So what will be the resultant? Let's do by the alphabet. The uppercase ABC is row 1 for the first matrix. So we have 2 matrices, no name. We have to multiply these 2 matrices. And the resultant is going to be 2 by 2. So we are ready for the resultant. Let's pick up the uppercase letters first. So we just write the A, B, C. Why we are adding it? Because it has to be row 1, row 1. There is no addition between these two. And we have to keep the column 2 and the column 2. So easy. Now I'm explaining it. I've taken the ABC, written it on the top, taken the DEF, written it on the bottom. The purpose is going to be a 2 column, 2 row matrices. Let's study it like this and we'll go a little bit slow. Otherwise, it will feel very tough. The decision came from the 2 by 2 matrices. What are the other values? Because sometimes step by step is harder. Now, let's pick up the columns from here. Let's pick up a different color, which is not. So, this is the value. Where should it go? Is the vertical part, right? So, let's see how it should be there. We take the A, the B, C. So, it was A, B, C uppercase. Copy and paste, make sure it's a 2 by 2 matrices. Now play with the smaller case. We write the ABC from vertical terms, write it with the A, with the B, with the C. And the same thing, we pick up the ABC, the DEF, write it there. So the vertical part, actually we have written it in the horizontal terms with the ABC, the DEF with the ABC. We have to repeat the same process for the row on the bottom. comes from the top, ABC written on the left. DEF was top to bottom, DEF was written there. Now next line, ABC, we just write left to right ABC. Over here, we will write the D, the E, the F, the smaller case. I've used the alphabets. It helped my students to understand it nicer, but the formal way in the book usually, now if we will solve this number, we'll simplify this. Usually it's done with row 1, column 1. So what is row 1? The entire part is row 1 and the entire part is column 1. Row 1 times column 1. See, the row 1 times the column 1 is in that location. Then we go for row 1, column 2. Row 1, the uppercase ABC, and write the column 1 side by side. This is second part is row 2, column 1. So R2, C1. Row 2 is the D, E, F, is the row 2. And the column 1 is the A, B, C, smaller case. And this zone is still row 2, but it's column 2. So we copy the row 2, D, E, F uppercase, and the column 1, D, E, F, the smaller case. Now, when we do the multiplication, I will rewind the video. I've planned for that. First, let's do the formal way. Pick this number and this number, A, or row 1, column 1, row 1, column 1. Multiply them. Take the 10, take the 5, put them under the multiplication sign. It has to be addition, right? So our goal is to have a complete term over here, like row 1, column 1. So the next one is going to be, the reason we put positive because they have to get simplified. Pick the 14 and pick the 7. Pick the negative 3, which is the uppercase C, and the smaller case C, which is negative 3. In both cases, it's a circumstantial issue. This is also negative 3. This is also negative 3. Now, before we proceed to the next line, I would like to just show some symmetry. Basically, we played with these two terms. Horizontally written, the vertical part is written horizontally. See the smaller case, see the row 1. This is done over here. Next term, and at the end I will show the rest. So the next term is go to the right. It's always left to right. Pick up the same number. Now it will get combined with the blue term. Second number is 14. Second number from the column is the 2. Second means from top to bottom is the second number. Left to right is the third value. Top to bottom, negative 1 is the third value. And we just pick it up. What we did, we picked up this 2 column. The horizontal part was written 10, 14, 3 horizontally. The vertical was written horizontally 6, 8, 1, but it was written from left to right. That's the DEF, or that's the column 2. I think if you just see it, maybe one more time, it should be easy. Or some student understands it in one go. Now pick up this column. We are picking up the DEF. DEF is the D value, the E value, and the F value, and it will get multiplied with the ABC, ABC, ABC. So it's 6 with the 5, plus it will be the 0 with the 7 gets multiplied. Everything is plus because we have to make it one time, is the negative 12 with the negative 1. Sorry, it's the negative 12 with the negative 3. Sorry about that. Is the F and C. Okay. And the last part is the uppercase D values, DEF, and the lowercase. So last term is going to be the combination of these two parts. So we write the left to right, take the horizontal, top to bottom, take the first one. plus get the 0. Second value from left to right. 8 is second value from top to bottom. Left to right is the last value from the left side, and the last value is -1 from top to bottom, multiplied together. Final part is simplification. And the simplification part is all these values will be one term. So this is, we need a calculator. If I bring the calculator, it will take more time. Basically, it's 5 times 10, 50, 4 times 7, whatever the value, 3 times 3, whatever the value, you can do it by the calculator. I've checked it, that value is 157. So I just color code it. All these value, that value is supposed to be 157. And all these value, 10 times 6 plus 4 times 8 with the -3, -1 will be 175. All these value, if we simplify, it will be, it's a very simple addition, but we need a calculator. It will be 66 over here. If there is a mistake, I apologize. I checked it many times. And the last part, I just use a different color. It will be, okay, let's use the white over here. That will be the last part. 6 times 6 plus 8 times 0 is 0, basically is 36. And this is a very small one. It's 6 times 6, 36. -12, -1 is +12. So the last value is going to be 48 over here. Now I take everything out. This is the resultant vector of this 2 by 3 and 3 by 2 matrices. Now just see the work, how it works, match the value, see it several times. It should be okay. But finally, the symmetrical part and the interesting part is how we came over here from these two. Erase how we came over here from these two. Finally, how we came over here is this value and this value. Left to right, top to bottom. And finally, how we came on the last value. So R1C1, R1C2, R2C1, R2C2, or we can play with the uppercase A's and the B's, and we are done. Looks very tough, basically it's very simple, but we have to be cautious and very careful about the results. Thank you for watching. In this video, we're going to learn how to handle the inverse of a 2 by 2 matrices. We know how to calculate row 2, column 2 matrices, but this time if we have a value, we are using the formula. This is very easy. If you have a formula, location A, B, C, D, A inverse of the matrices is going to be, it's just a formula. It's going to be 1 over this A and D, left to bottom right. We just write the A times D. Subtract the B times C. And we can, students are allowed to use formulas from the formula sheet. But this value on the matrix, A and D, they just switch their location and position. They switch the location. A goes to the location of D, D goes to the location of A. B and C remains to be same. The positive B or whatever the value, this value gets negative. That's it. So we will use the formula to solve. If A is 4826 matrix, the A inverse, we have to know how the A, B, left, right, A, B, C, D works. Is going to be 1 over. Just look at the formula, A times D. Over here, A is 4, D is 6. So it's going to be 4 times 6. Minus, the formula says B times C. B is 8, C is 2. So it's going to be 8 times 2. Just apply the formula. Then with the matrix box, the A and D they switch their position. So 4 and 6, they will just switch their position. And B and C, which is the 8 and 2, they will just get negative. Now it's simplification. This value, this is a 6 times 4, 24. Let's just use the 6 times 4, 24, and it's a negative 16. So 1 over 24 over negative 16 is going to be 1 over 24 minus 16 is 8. So we simplified that part as a 1 over 8. Copy the matrix the way it is. Now we have some number 6, 8, 2, 4. Every number can be divided by 2. So we keep the we keep the 1 over 8, decide to factor out a 2. Basically, we will divide every number by 2 and write the value in this box. So divide the 6 by 2, divide the negative 8 by 2, divide the negative 2 by 2, and divide the 4 by 2. The numbers are too small, that's why I haven't read it. How to divide the 3, 6 by 2, the negative 8 by 2, and all this by 2. And when we are done, keep this value. We can't factor out anything. Keep this box. 1/8 times 2. Double of 1/8. Double of 1/8 is a quarter. Or we divide the top by 2, divide the bottom by 2. So it's a quarter times the box. That's the inverse of these matrices. We have another 2 matrices, has to be multiplied with each other, but this time we are not proceeding by step. We will have a synthetic manner. We will just use the blocks and finish it in fast method. So this is row 3, 2 column, the 3 times 2 matrices. The second one is 2 rows, 1, 2, 3 column, and the end result is going to be a 3 by 3 matrices. This is what we need to know. And we have to organize our plan like this. So we just keep our space. That's the result of the multiplication of these 2 matrices. We're going to have 3 blocks here. And we're going to write the 3 blocks, simplify, and finish the job. So the first one is pick up the first column from here. And the second is pick up the second column from here. And copy it, organize. So first we just copy 1, 2, 4. Then we copy 0, 5, 1 as positive. From the second position, we just copy the 1, 2, 4 again. From the left side, the right side, we copy the 0, 5, 1. And for the last column, we just do the same thing. So it's repeated of 3 steps, similar steps, same steps, repeat 3 times. Now we have to simplify it. Now, this first column has to get multiplied by that 3. All these numbers has to get multiplied with 3. So we just put 3 over here, multiply 3, multiply 3. Then we use the second column from here and multiply it by that 2. So the first block has been done. Everything will be in the first column when we simplify. Now, as we move to the next one, this column has to get multiplied by that blue one. So same number from here, but we are on the second column now. And the 0, 5, 1 is going to get multiplied by the 0. So this is multiplied by 0, 0, and 0, all these 3 numbers. And when we move to the last one, again we pick up the first column number from the first block. We do the same repeated number, it's just the values are different. So this same 1, 2, 4 is going to multiply by the -1, -1, and the -1. And the last part, this value is going to get multiplied by the -2s. And we are done. It's just about the only one thing we are left with simplification. Now we will simplify this value, simplify this value, and simplify this value. And we will proceed with a block system. So 3 times 1 is 3. 2 times 0 is 0. 3 plus 0, this is 3. First column, first row. First row, second column is going to be 1 times 1, 0 times 0. So final answer is 1. The last one is going to be -1 times -1 is a -1. 0 times any number is 0. So this is going to be a -1. Now we move to the next one. We will simplify this one, simplify that one, and simplify the third one. And as we proceed, is going to be 3 times 2, 6, plus 5 times 2, 10. 10 plus 6 is a 16. Then it's 2 times 1 plus 5 times 0. So it's basically 2 plus 0, which is a 2. And that one is negative 1 times negative, sorry about that. 2 times negative 1 is a negative 2. Positive 5 times negative 2 is a negative 10. So negative 10 and a negative 2 will bring a negative 12. And the last part is this block, that block, and that block. So 4 times 3 is 12, and 2 times 1, 12 plus 2 is a 14. Next block is 4 times 1 is a 4, 1 times 0 is a 0, 4 plus 0 is a 4. And the last one, 4 times negative 1 is a negative 4, 1 positive with a negative is negative 2. So negative 4, negative 2 is going to be a negative 6. And that is our final answer. We just did everything, skip the steps, did it by the block, and it's very fast and very easy. Thank you very much for watching. This is, we call it the synthetic method.